And I'd like to welcome everybody also who's online with us today. So this is the Distinguished Lecture in Statistical Sciences. This lecture is sponsored by in Kansas, Ontario. And before we introduce our guest, I'm going to tell you a little bit about Kansas, but first acknowledge the land that we are sitting here on today. So we wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still the home to many Indigenous people from across the island, and we are grateful to have the opportunity to continue to work on this land. So Kansas, Ontario aims to strengthen and enhance research and training in statistical science by developing programs that promote interdisciplinary research and enable multidisciplinary collaborations. I hope you will all check out our website and all of our programming. But before I mention any of the programming, I would be remiss if I didn't mention our speaker today and her contribution to Kansas and Kansas, Ontario over the years. I won't take away from the intro of Nancy by Kelly, but I did want to mention that Nancy has been really integral in the creation of Kansas. So she chaired the long-range plan steering committee for mathematics and statistics, which shaped Canadian national policy and really led to the establishment of the Canadian Statistical Sciences Institute, which is why we're all here today. And she served as its second scientific director, really guiding the Institute through critical formalization and growth and funding that has led to all the programs that we can offer today. She also established Kansas Regional Centre in Ontario, which I have the privilege of directing currently. And she joined Kansas, Ontario's Provincial Advisory Committee that same year to really help us to create programming and infrastructure that could support Ontario's statistical sciences community. And she continued with this institutional leadership of Kansas through its Board of Governors following her directorship. So Nancy has been so integral in Kansas and the support of the statistical sciences community, and I just wanted to highlight that today before I mention all of the fantastic Ontario University members that are part of Kansas and Kansas, Ontario, and we're here to support all of you, and we really hope that we're providing programming that appeals to you, and please get in touch with us if you have ideas or if you have needs that you think we could help support. I won't go through all of our programs, but we have lots of different activities. Check them out on the website. These range from events to grants to data access to student groups. So please check them all out on our website. And with that, of course, all of the upcoming events, but we're here today to talk about, to hear from Nancy Reid. So I'm going to now pass it over to Kelly to introduce Nancy, and I hope everybody will join us today and tomorrow for a wonderful two-set of lectures.
Hi everyone. My name is Kelly, and I'm a professor at SU and the chair of the selection committee for the Distinguished Lecture Series. So we selected Nancy this year, and quickly, just before I introduce Nancy, I have to put in a plug that we're looking for 2 new members and 1 chair. So if you're interested in selecting our speaker or having a role in selecting our speaker for next year, please get in touch with me or Esther. Okay, but we're here for Nancy. So Nancy's research has helped shape modern understanding of statistical inference and its foundations through her mastery of statistical reasoning. Okay, so she is internationally recognized for her pioneering work on likelihood inference, I think especially conditional inference, okay, including higher order asymptotics and the development of methods that improve the accuracy of likelihood-based approximations. So Nancy studied at a variety of top rated universities, including Waterloo, UBC, Stanford, and Imperial College of London. And then she joined the University of Toronto in 1986. So Nancy has so many accolades, so I'm just going to list a few, but the ones that stood out to me, aside from her contributions to Nancy, which I'll skip now, but Nancy was also the first woman to hold a Canada Research Chair in Statistics. Okay, she's also won the COPS President's Award, the Krieger Nelson Prize, and the Florence Nightingale David Award. She's also a fellow of the Royal Society and the Royal Society of Canada, and the Royal Society of Edinburgh, and the Foreign Associate of the National Academy of Sciences. And also in 2015, she was appointed Officer of the Order of Canada. So we're all very excited to have Nancy here today, and I hope you enjoy.
Thank you. Thank you all for coming, and thanks to those online who are joining. I was at the first Distinguished Lecture Series in Statistics. I don't know how many years ago it was because I try to forget how many years go by, but I'm pretty sure the speaker was Peter Hull. So I feel like I'm following in some pretty big shoes. So I'm going to talk kind of about teaching, but in a way about teaching/research. So in 1995, that was the first time I taught a freshman first-year seminar. It started in 1994. It was an idea of our dean at the time that first-year students at the University of Toronto should have at least one small class, because most of them were in very large classes. And she kind of railroaded all the departments into teaching these 199 courses. And they were described as undergraduate seminars that focus on specific ideas, questions, phenomena, or controversy. Okay, so back to first year. 1995, a long time ago, 30 years ago. And I thought, oh my gosh, what else? How am I going to teach this course? And I have no idea where to even start. So I stole a quotation from my title. And it turns out, it was attributed to Mark Twain as far as I knew, but it does appear in his autobiography, but apparently it was quoted by Disraeli and attributed to many other people. And it turns out if you Google long enough, you can find there's a whole long list of these quotes about different types of lies, and they always come in triples. But this is one that was around in the air for statistics, and the one that I used. So this is back to 1995. I have a rather long description here that I wouldn't expect you all to read. My children were quite young, and I was much younger. And I tried to make it sound sort of interesting. But the one thing that I was going to note, that I noted when I looked back over all this, was one of the things I had was, one of the topics was what is quality control? And why is it currently so fashionable? And that's something that's really not so fashionable anymore. Or, I mean, it's obviously important, but it's maybe been absorbed into the mainstream in a way that we wouldn't emphasize it in a statistics course. So part of what I was thinking about when I was preparing all this was what's changed, what's stayed the same, and so on. The last time I taught it was in already more than 10 years ago in the fall of 2014. And by then it was a half course, but it's still the same idea, and I changed the questions a little bit. Of course, the girls grew up and I grew older, and tried to address some things that were more current at the time. So in particular, for example, I have in this description, what does statistically significant mean? And that's because most people by then will have heard of statistically significant just in the media, whereas in 1995, that wasn't necessarily the case. Okay, so that's just a few of the changes, but I wanted to describe a few other things. I taught it several times over the years, and it kind of changed slowly, but when I look back on it, it kind of changed a lot. So in those days, of course, I got hard copies of the newspapers, and I would trace them back to the journals, but that meant taking a trek over to the Gerstein Science Library to actually get the hard copy, and sometimes you had to wait 2 or 3 weeks before you got it. Because what I should have said, what I focused the course around was pick a headline. It's commonplace now, but at the time maybe not so commonplace. pick a headline, follow it back to the source, see what's underlying the headline, and try to explain some statistical ideas to the uninitiated through that mechanism. So there was a lot of walking involved. Here's one that I used in the second time I taught the course. I used to actually cut things out of the paper and stick them in a folder somewhere. How arcane. I don't know how well you can read the headline that says the welfare recipients found jobs. And so this is a blow up of the statistical part of this article. So the context was Conservative government elected in Ontario. They cut the welfare rates payments by 20% in one blow. And then they did a study a year later, and they found that the welfare recipients found jobs. And they published this in the Globe and Mail. And of course, it's a survey, so the fine print says the research company's telephone survey looked at randomly chosen people who left the system in May. It is considered accurate 19 times out of 20, plus or minus 1.6 percentage points. Well, that's sort of true if you are counting jelly beans, but they are phoning people who lost their welfare, phoning them in the days when a phone was expensive, and you might be expected to be maybe not paying your rent if you didn't have any more welfare. So the non-response rate is terribly confounded with people who have lost their welfare. So this was pointed out right away by a savvy journalist. It's nothing special about that. It's just that it's kind of shocking that something that obvious could get past the editor of the Globe and Mail, I guess. By 2014, I never went to Gerstein. And I didn't even look at most of the newspapers. I used Twitter and various blogs and a great Radio 4 program that I recommend to everyone. And I never left my office. I just stared at my computer screen, and that's pretty much how it is today as well. I mean, there's a lot of negative things about the internet, but one of the positive things is that there's really quite a bit of information quite readily accessible, which is quite helpful for teachers and among many other people. Of course, now it's 2025 and Twitter sucks, and and these blogs have kind of faded into irrelevance, and more or less is still going strong. It's still a great show, and I basically rely now on a lot of podcasts. So kind of the social ambience changed, but the main ideas didn't really change. Lots of books coming out around this time, kind of science books that are targeted on non-experts. When I started in '95, I relied quite heavily on the visual display of quantitative information. And I still love that book. It's a little bit out of date now, but it's got some lovely pictures in it. But partly I did that because I realized I was getting students who had no quantitative background at all, but I figured they could all look at pictures, and that would be a way to get started, but also a crutch for me because I was nervous of teaching without a textbook, basically. Over the years, I think that the three books that have really been the most successful are that book, Seeing Through Statistics by Jessica Utz, and Jeff's book, Struck by Lightning, which I highly recommend. And whenever I used it in the course, the students really liked it. It really rang in with them. The book by Jessica Utz presents a lot of the similar material. Once it's in a book, it's not quite as lively as it is when it's in the news, but the same ideas come up, as we'll see. I wasn't the first to do this. There was a great course at Dartmouth College called Chance, and it was written up in Chance magazine. So I drew a lot of inspiration from Laurie Snell's course. He even had a conference, a kind of workshop for people to discuss their Chance courses that I went to, and so it was in the air at the time. And of course, there's lots of people in our department have done similar things. I'm not claiming any particular originality here. I do wish I'd chosen a more dynamic name than Statistics in the News or Lies, Damned Lies, because this course, Bio 270 at the University of Washington, got all kinds of press all across the U.S. because they called the course Calling. You can read it. They can't use that in their calendar. That's the calendar entry here has it starred out. You can't probably see that, but it's a similar idea. It's a little bit more broad-based in covering more science and not just statistics. But I often thought, after I saw this course emerge about maybe 5 or 10 years ago, I thought, oh, if only I'd had the courage to give it a more dynamic name. So a typical week started with a handout. Don't read the handout. I've got a list of what the things are here, but there was some coursework at the beginning, of course, and then some articles from the news. And then I would take those articles from the news and try to develop a theme on one or more of them and try to convey some statistical ideas. You'll see what I mean in a minute. This stock market graphics one I highlighted because I was so surprised to find this clipping in my files. Apple's iPhone shakes rivals to the core. That was only 2007. It wasn't that long ago. And on the little graph on the side, so we're studying graphs as well, you can see the stock prices of Motorola, Palm Incorporated, and Research in Motion going down, and Apple stock going up, and I guess that's kind of been like that since 2007. Just keeps going up. It would be on the 18th floor by now, I guess. This was a particularly memorable one among many of the titles that I used, or news clippings that I used. Long-use drug shows new promise for cancer. This actually really annoyed me because of the hype that it got. I've highlighted the main parts. Imagine, if you will, a drug that shrinks cancer cells and can make tumors disappear. No nasty side effects. It costs only $2 a dose. That was all in the first few paragraphs of this article. I thought it was almost irresponsible of André Picard to write that. So not too good to be true, according to a Canadian researcher. This is one of the most exciting results I've ever had. He said, well, okay, that's fine, but he was more measured. He said, but I can't be over-enthusiastic until it works in a human being. So this is one of these many, many studies that you see in the news where something does something amazing in mice, right? So this is in mice. But it was, so I remember railing about this with the students when we used it in class, and following back the article. I mean, the article was interesting, and you could track it through, and you could find out how many mice he used, about 5, and how long it ran for, and so on. So I really felt it was like a teachable moment. But I was curious for this talk what had happened since then. So I looked up what I Googled, of course, like we all do now, to see what the status was of this particular treatment. It's called DCA. It has a long chemical name that I don't remember. Dichloroacetate. I wrote it down, so DCA. And so in 2023, there was an article, a 15-year evolution of cancer therapy. In 2024, there was a review paper, dichloroacetate for cancer treatment, some facts and many doubts. That was all I could find. I didn't look for a really long time, but these are not top journals. The first journal is ranked 3,092 among pharmaceutical medical journals, and the second one, position 1,000. So these are not great journals. So there's not a lot of research going on. And it seems to be the case that there's not much research going on because it's cheap and people can buy it, so there's a lot of off-label use of it. Because of this hype, there's a last ditch. I mean, people are desperate and they'd try it. So it's never been tested in phase 2 clinical trials. And we strongly discourage the use of it as a compassionate treatment until well-planned and supervised studies are conducted. So I think that it's a kind of negative example to start with. I hope my others are more positive, but of how this type of hype can really get overstated and really affect things over a long period of time. And in fact, to give him credit, the researcher who was quoted was worried about this at the time the article was published. He said he was worried that people would start using it and then there could never be a trial of it. Of course, another reason there's not a trial of it is it's very inexpensive, so there's no profit in marketing it. Okay, so that's a sad one. I hope I have some more interesting or more upbeat ones coming along. I will say, though, that although I didn't teach 199 that often, the first year seminar, I found this headline stuff to be completely addictive. I'm totally hooked on it now. I can't stop. And I use it in all my classes. So I picked a few from different classes that I've taught just to give you a flavor for it. When I taught survey sampling, there was a nice article about the freshman 15, which is you put on 15 pounds and your grades go down 15% in your first year of college. And so that was based on a survey of students. So I used it in that course. When I taught statistical computing, I was really lucky because there was a headline in the New York Times about the estimate of the effect of particulate pollution on mortality in the United States. And they had to redo all their analyses because they'd used a default, what's the word when you have an iteration running and you stop it after so many iterations because there's some critical epsilon, and as soon as a difference gets less than epsilon, the optimization stops. They'd used the default value for that, and when they ran it with a different value, they got completely different results. So this meant that all the work that they had done on air pollution and morbidity and mortality had to be redone, which it was redone. This was all from the Health Effects Institute in the US. But that was a great example for a statistical computing course because it really had a big impact. When I taught data mining and machine learning, I was really lucky because the Netflix prize had just been announced, and that was by an ensemble team from Bell Labs, $1 million prize. Apparently Netflix had planned to run a second contest, but they didn't because it was too easy to use their data to actually identify individual viewers, it turned out, through a lot of slicing and dicing. In applied statistics, we often looked at this one. This is a story that never seems to die, that Oscar winners live long lives. Nominees and other actors don't last as long. Of course, as soon as someone tells you that, you can think of all sorts of reasons. Of course, if you win an Oscar, you'll be richer, your life will be more comfortable, you'll have a personal trainer and so on. But actually, you have to live long enough to get the Oscar, right? So there's a bit of a bias built in there. In design of experiments, so there's tons and tons of them. This paper I used in a design course was about a randomized controlled trial on ethics consultations. So just a sampling of what's been done over the years. Even in my statistical theory courses, when I taught topics in likelihood inference, I got really lucky because there was a likelihood curve in the Financial Post that year. And it even says percentage likelihood in the heading. It's actually just a probability curve, but because it says percentage likelihood, I often use it in likelihood talks. And when profs draw a likelihood function, they almost always draw a quadratic that looks like this. This is probability of depression by age. So if you're to the left of this curve, I'm sorry. But if you're over here where I am, things are looking pretty good. When I taught the theoretical statistics to the PhD students, there was a whole series of papers in Nature about scientific irreproducibility, some of which relates to p-values and their misuse. So that's another topic that is important for the study of theory. And in recent years, I've been teaching the master's course in mathematical statistics, and last year we used this one among many. I usually have one every week, but I thought they might be interested in this because this was a counterintuitive result, but the result of a natural experiment where some schools in a particular school district banned phone use and some other schools did not. So they had a kind of not quite randomized experiment, but they had a kind of natural experiment, which you do tend to see more and more of these days. Okay, so in preparing for this talk, of course, I did the same. I started looking for some headlines that I thought would be interesting. So depend where you are on that likelihood curve, you may or may not be concerned about Pilates. Happy birthday, LIGO, now drop dead. That was kind of an interesting one because it's not directly statistical. It has to do with the funding that's been cut for the LIGO experiments. But some of the aspects of the LIGO experiments are statistical. So with enough work, you can find statistics there. The CBC News in July said that the heat wave in late June and early July in Europe, a study estimated that there were 1,500 excess deaths due to climate change. I'm going to come back to that one. More or less at the end of the summer had a study on whether or not self-driving cars are safer than cars with drivers. There's a lot on global warming, of course. And this one I thought was kind of fun. This was in my inbox. Utah researchers find decreased risk of skin cancer in those with tattoos. So I'm going to go through this one in a little bit of detail. And I'm also going to go through the Europe heat wave in slightly less detail. So depending on the time that I have in my classes, I delve into these headlines in more or less detail, and depending on whether it suits the topic at the time. So I just give you an example of what I do. So this seemed kind of like this might appeal to students, I'm guessing. There was a press release on September the 17th from the University of Utah, the Huntsman Cancer Institute, and typically that's how they get to the news. This gets picked up by other news organizations. It got picked up by Sigma Chi Smart Brief, and so it ended up in my inbox. Tattoos may help reduce the risk of melanoma. And it's all based on, of course, a scientific publication, this one in late August in the Journal of the National Cancer Institute. So I always end up going to the source. So I'm at the journal, so I didn't have to walk over to the library, but I'm getting a few messages about my speaker, sorry. And of course, I don't have time to read it really carefully, so I end up always turning to the methods section as my first pass, and that's what I tell the students to do as well. I look a little bit at the introduction and then switch to the methods. So this is too small for you to see, but I've highlighted some of the main things. This was a retrospective observational study. It was a case control study, in fact. So they identified all the melanoma cases, and they found 5 matched controls per case. The melanoma cases they found in the hospitals, at the hospital connected to the Cancer Institute, although they were actually not able to talk to 60% of those, so they had a lot of missing data. And they had some survey data to give them some matched case controls. They were matched on sex, age, and ethnicity. And this will be familiar to the statisticians. We computed odds ratios and 95% confidence intervals from logistic regression models. So in a sense, you could use this for almost any course. For a survey course, it's non-response. For a basic course in stats, it's logistic regression after you do linear regression. Not too hard to do odds ratios. They also had some more sophisticated, or what we think of as more sophisticated statistical bits. We created a directed acyclic graph to identify confounders. So if you're teaching a regression course, you're going to be discussing confounding variables, things that could blur the association between tattoos and cancer. And there's some data not available because the controls are from a survey, so they don't really have much information on melanoma risk factors. So they don't really know if the controls, the people that didn't have melanoma, had various risk factors. So maybe if you felt you were at risk of getting melanoma, maybe you wouldn't take a chance in having a tattoo, that sort of thing. They used propensity score models, so that's a more advanced topic again for exploring potential confounders. Kind of sounds like my mic turned off. Is that true? All good? Okay. So if you've done this, you'll know there's always these pages and pages of results. Here's a whole table of results, lots of small numbers, lots of confidence intervals. I think there's actually, I counted several times, I think there's 22 confidence intervals here. They're all down this line, and under the overall, the odds ratio, there's all the confidence intervals, and then invasive. So overall is for both types of cancer, in situ or invasive, and the other line is for invasive cancer. And there's lots of stuff down this side, like first, were ever tattooed, yes or no? So there you can see that the odds ratio for melanoma relative to having a tattoo relative to not, the odds ratio is somewhere between 0.74 and 1.13. And the magic number is 1. That means there's no difference. So there doesn't seem to be any association of melanoma risk with ever having had a tattoo or not. But they looked at a few other things, of course: time since first tattoo, age at first tattoo, number of tattoo sessions, number of large. And sure, buried in here, there's some confidence intervals that don't include 1. They're not very many, but there's a couple. So I highlighted them here. There's 2 intervals that don't include 1. This one, 0.44, is the estimated relative risk. So this is like a protective effect of tattoos on melanoma, which is a little bit unexpected. In fact, the researchers said they didn't expect this. And the confidence interval doesn't get anywhere close to 1, so it seems to be statistically significant. But there are only 24 people among the 6,000 or 8,000 that they started with that had 4 or more tattoos. And there's a significant, statistically significant result among the number of large tattoos. But there's fewer than 11 people in that group, so they didn't even tell us how many because they were worried about disclosing too much information. So I think, like most statisticians, we're a bit skeptical. We take this with a grain of salt. And really, the authors were skeptical as well. These findings should be considered as generating hypotheses for further study. Part of the reason they said this was because they were expecting the opposite. They were expecting to see an association, positive association, an increased risk of melanoma. So they mentioned that the biological mechanisms are unknown, and there's a high likelihood of unmeasured confounding. And these are all kind of related to what I call the Bradford Hill criteria for causality. So observational study, but we want to interpret it as causal. Then you need a bunch of things to fall in line: a dose response, biological mechanism, as far as possible, ruling out unmeasured confounding, and so on. It's possible that people with tattoos, I mentioned this already, have fewer risk factors than those without. We were further limited by the low response proportion among the cases, and future larger studies are needed. So, here I am again being a little bit negative, like the study looked interesting, but now I'm saying, yeah, don't believe it, folks. So it's a little bit unnerving when you're teaching these to always be so skeptical, and I always try to find a positive one to kind of make people feel a little bit better along the way. I honestly can't remember if my next one is positive for you guys or not, so I'm sorry. But this is also kind of interesting. This is from the press, so a few different things, but the most irresponsible came from, I guess, from Yahoo News. Getting that tattooed arm sleeve of or back design of your dreams might protect you against deadly skin cancer, a new study says. It doesn't say that at all. They eliminated all the people who died, for starters. Any cases they had who died of cancer were taken out of the study. So the skin cancer itself could be deadly, but they didn't have anything to say about that. And of course, they don't have any evidence that it protects you from getting cancer. They only have observed an association. And so there's no evidence of causality. And they were quite clear about that. It's just the press wasn't very clear. There's other studies on tattoos and cancer, as it turns out, and most of them show that there is an association, but in this case with lymphoma and skin cancers. There's, again, so you could also go down this path and say, yeah, there's a whole other host of studies from earlier in the year that show that there is an association, which is why the researchers in Utah were expecting to see a positive, not a negative association. Okay, that's that one. Maybe this is not so happy either, all those excess deaths. Sorry. But it's interesting. Well, it's interesting to me. I hope to you. The headline was from the CBC News. The source was from a report from Imperial College, Climate Change Tripled Heat-Related Deaths in Early Summer European Heat Wave. And it has to do with an approach to attributing, it's a relatively newly developed approach to attributing weather events to climate change. So as recently as 5 years ago, you would hear scientists on the radio say, oh, we can't say that this hurricane or this wildfire or this flood or this heat wave was due to climate change because weather and climate are different. They're on different time scales. We know that climate change will cause more variability in the weather, but we can't really attribute any particular event to climate change. But there's been a kind of change in approach, partially due to this group that's working at Imperial College and some other groups around, where they do try to attribute exactly to climate change. And the methods are fairly well established now. They first examine trends for this paper, and I'm really high level, I'm not really drilling down, but they examine trends in heat extremes using some data, but mostly climate models, these big, huge climate models that the climate centers run all the time. They create a series of what they call factual and counterfactual temperatures. The counterfactual is just actually 1.3 degrees lower than the current, because the best estimate of the average global warming to date is 1.3 degrees. They use a regression model to relate temperature to whatever they're looking at, in this case, deaths. And then they create an estimate of expected mortality, and they compare that under factual and counterfactual temperatures. And they look at the mortality risk, and then they have another regression that enables them to convert that to a heat-related mortality risk. I'm really not explaining this very well because I don't understand it very well. But the general approach is always the same. Simulate some climate, today's climate, what it would be if there wasn't global warming. Relate that temperature to the probability of a wildfire or an excess mortality or the probability of a flood, and then predict what would have happened under the counterfactual. Maybe a picture is worth 1,000 words. This is taken from their paper, and this is the number of excess heat-related deaths. Under the climate is the orange line, and under what they would expect if the climate was cooler is the purple line, and they attribute the difference to the difference in heat-related deaths to climate change. It's a big step to attribute it to climate change, I think. It seems like a big step. But they've tested the methodology in a lot of different settings. So this is a quote from the paper. We used established epidemiological models and the World Weather Attribution Climate Attribution Framework to estimate the additional number of heat-related excess deaths that occurred due to anthropogenic climate change. So there's a whole group, the World Weather Attribution, and you can see from their webpage that they attribute various extreme events to climate change, and they always use the same methodology, and you'll find common names among the authors in all these publications, and they all refer to this original protocol paper. This outlines the method by which they attribute extreme events to analyses, and it's quite a detailed protocol. So many questions. I mean, there's so many questions that you could ask at any level of teaching classes, right? Like, well, why did they pick this one? Why did they pick the heat wave in July? What about the heat wave in August? If you only do this attribution when there's a big event, are you really getting the whole picture? I mean, there's just so many different questions, each of which has some kind of statistical aspect to it. Okay, so those are my examples. I'm not sure what time I started and how much time I have left. Is anyone keeping track? 4:15. Okay, thank you. Okay. Yes, okay. Yep. Okay. Okay, so I just make a few observations about the teaching part of this. I hope I've convinced you there's absolutely no shortage of material, although there were many weeks when I sat down the day before to prepare my lectures and I thought, oh, I'm not going to be able to find anything. I haven't heard of anything on the radio. I hadn't seen anything in the paper. I'm not going to have one this year. I'll have to pull out an old one. And then somehow something comes up. I mean, always. I've never had a day where it didn't. What surprised me a little bit was that the core set of topics emerges again and again. So we aren't wrong to teach Introduction to Statistics. It's a good course because these topics that appear in every introductory class and have for years, they do come up over and over and over. I mean, well, perhaps there's a bias because I'm looking for them, but yeah. And the same topic just keeps coming back. The students seem to appreciate it, and it's a great source of homework problems. And for me, it helps to keep the material fresher. I just find it more exciting to teach if I can relate it to something that's very current rather than, because I've been here a long time and I've taught the same course many times, and this helps me to stay energized, I guess. So these are the basic stats topics that we teach in our beginning courses that come up over and over and over in anyone who's paying attention to science and society. Here's a few topics that don't come up maybe in the first course in statistics, but they do make an appearance in many news items, life tables, survival data, time series, ethics, stochastic processes, extreme values. Now extreme values comes up all the time. A few years ago it didn't. Meta-analysis comes up quite often, measures of risk. And some stories just never die. One of them is chocolate. This was from 2005. This was a headline on the front page of the Globe and Mail, "Can Chocolate Save Your Life?" Which definitely seems overstated, of course. Another one that's come up many times that I first noticed in 2006 was a new study estimating the number of dead in Iraq. This was really interesting to follow. It started with a survey during the Iraq War, and kind of a very well-designed but unusual type of a survey because it was so dangerous to go and do some sampling in the streets, but they did have local people sampling in the streets, and there was a lot of pushback that the number they estimated was much too high because they happened to sample in more dangerous neighborhoods and so on. So there was a lot to study about that one. It was really quite interesting. Don Rettelmeyer published this paper in 2001. I mentioned it earlier, Survival in Academy Award-winning Actors and Actresses. Bad graphs come up all the time. This is a bad graph from 2007. It is totally meaningless. If you can see the numbers, the people who are laughing can see the numbers because this number is 700,000 and this number is 300,000, and they're basically at the same, almost at the same level. So USA Today is a great source of bad graphs. and bad graphs are fun. Good graphs are fun too, but bad graphs are good fun. So chocolate, these are all from 2025, more chocolate. Chocolate intake and the risk of type 2 diabetes. Actually, that's from 2024, December. I used it last year in my class. The Gaza war toll likely significantly undercounts deaths. This is from CNBC in 2025. Academy Award winners live longer than nominees, studies show. So a whole article about this quite recently. That first paper was in 2001. And then James Hanley wrote a rebuttal paper saying they didn't account for immortal time bias. You have to live long enough to be nominated a few times. And then they came back and said, yes, we did account for immortal time bias, but we did it this way, not this way. So it's also a good exercise in seeing statisticians argue among each other, if you like that kind of thing. And there's a great bad graph recently in USA Today showing how Jimmy Kimmel got more attention than he would have otherwise, thanks to various current events. I decided when I was getting ready to prepare this talk that I wouldn't talk about AI, and I wouldn't talk about the President of the United States. So this is as close as I'm getting. The chocolate one is fun because you can count on it being there almost all the time. This particular study had 10 women and 10 men, and they ate dark chocolate for 4 weeks, and then they ate white chocolate for 4 weeks. And their systolic blood pressure changed by 11 points, which is substantial. In 2009, there was a meta-analysis of all the randomized controlled studies. And so they plotted one of these meta-analysis plots that's also a little bit teeny for you, but the big diamond at the bottom you can probably see, and that's the average of all those studies. And so here's like 11 different randomized studies, and they all studied dark chocolate or cocoa products on blood pressure. And there's the one, this little tiny thing over here, that's the -11, that's that study. So clearly most of the studies were much closer to no change, but this one study just happened to be a bit of an outlier. 2010, another one, an ounce of dark chocolate prevention is worth a pound of cure. That was a large observational study, but that blood pressure change was only 1 unit, so that's not really very meaningful. But again, 2022, the New York Times is chocolate good for you? And this study, maybe it'll be the last one, I'm not sure, because it's a study of all the meta-analyses. So it's a meta-analysis. But I mean, it's silly and it's fun, and they always publish these articles around Easter and Christmas because that's when everyone's eating chocolate. But also kind of drives home the point that there isn't like a study that solves the question, right? So statisticians and scientists are famous for saying more study is needed, but these are difficult problems. If it was obvious that chocolate would save your life, we'd all be eating lots of chocolate. These things are small effects that may or may not tip the scales, and it takes a lot of time to figure this out. The 2025 one, so no, it's not the last word, because this was chocolate intake and risk of type 2 diabetes. And this was in the British Medical Journal. I guess it was in December. I think it was December 24, but it might have been January 25. Again, one of these sets of lots and lots of confidence intervals. It doesn't matter what they are really, but there's only one that's really of interest, and it's that one right at the bottom that shows a relative risk of 0.79. So let's call it 0.8. That's a 20% risk. Reduced risk of getting diabetes in this prospective observational study relative to not eating any chocolate. And this is 5 or more servings per week. So you have to scroll through lots of confidence intervals to find a result. But of course, that's the result that gets put in the abstract and gets picked up by the news releases and gets put in the headlines. And so, again, grain of salt. Sorry to be so negative. So maybe this next slide is a little bit more positive. I'd say things are improving for many different reasons. I did hear Anna Maria Tremonti say on CBC News, plus or minus, this poll is accurate to plus or minus 3 percentage points 19 times out of 20. And then rather apologetically, she said, we have to say this because it's a poll. So somewhere along the way, the CBC management decided that every time there's a poll, they would have to say this. Of course, this is only valid if the poll was well conducted and so on. But this kind of thinking that, the statisticians have made some kind of a hoop that we have to jump through. That's quite common in science, and I think less common now than it was, but very, very common, say 10, 15, 20 years ago. There was another one. This was hilarious. This is the city of Toronto hired some actors to pretend to be homeless so that they could estimate the number of homeless by a kind of capture-recapture method. So capture-recapture usually is described as a pond of fish. You scoop out some fish and you mark them, you put them back, and then you scoop out some more and you see what percentage are marked. and you guesstimate that percentage. If you caught 10 fish and 3 of them are marked, that 3/10 of the fish you caught the first time, so you can guess how many fish there are in the pond. So fish in the pond are homeless, and we have some marked. They're actors, and it was this kind of recapture design that they were using to estimate the number of homeless. Well, several people kind of thought, gee, how much did you pay the actors, and could you have spent that money on the homeless instead, and so on. And I did hear one of the interviewees say, we had to do it this way to make it statistically valid. So I would say that was then. Now, so I'm getting dangerously close to the U.S., and someone I didn't want to talk about, but I was really impressed with the response to this from the press. It was really quite sophisticated. There were immediately many people talking about confounding factors and other studies, and I heard the words many occasions correlation is not causation from journalists. And there was talk about genetic links and bigger studies that were better carried out, and it was really quite quick, and I was very impressed. So I think if there is a bit of an upbeat message, then I think there's a lot more appreciation, I would say, these days for statistical thinking and the importance of statistics. And that's something that I've been really, really happy to see in my career. It's changed. For me, it changed in 2014 when I taught that last 199 class. Every year that I taught 199, I asked the students, because they're first-year students, they get to choose one first-year seminar. And so they picked, their top 5 or their top 3, I'm not sure how many. And every year I would ask them, how many of you put this course as your top choice? And consistently from 1995 to 2009, when the last time I taught it, nobody put it as their top choice. They'd all put it as their third choice. They were all there because it was all that was left. In 2014, they'd all put it as their top choice. I thought, not all, maybe 2/3. I'm exaggerating. Something has changed. And then maybe a year or 2 later, or before, I'm not exactly sure, like a neighbor, not an academic or a scientist or anything, came to dinner. I want to talk about statistics. Don and I were like, what? You want to talk about statistics? That's great. I think that things have really changed a lot, just maybe in the last 10 years, I would say, that somehow statistical thinking is now considered a really important part of life and of general knowledge, and there's more interest in it. Of course, now everything's, well, no, I'm not going to go to AI because I don't know anything about it. But let me just say some other thing, just sort of things I've noticed about how things are improving. There's more tutorial articles. I mentioned this protocol for extremes. There's in the Ecology Journal, there's writing statistical methods for ecologists. There's lots more explainers around in the journals. The Nature has a whole series called Points of Significance, where people just write 2, 3, 4 paragraphs about some statistical topic. JAMA has something similar. I joined a statistical review committee for the proceedings of the National Academy of Science. This was a direct reaction to complaints that the statistics in some of the papers wasn't up to snuff. So there's now a review committee just for the statistics. So I mean, to kind of drive home that point, I'm getting to the last of my slides now. I've picked out some haphazard examples. I've got hundreds of them. I wish I knew a way to kind of make them into a cohesive whole, but so far they're just everywhere. There's statistical issues of sampling bias, reproducibility, p-values, and so on, much more prominent. There's still a few communication gaps. I'll close with this one from Science. Also in my inbox, heart failure causes sleepless nights. Well, maybe, but in fact, it's immune-mediated denervation of the pineal gland underlies sleep disturbance and cardiac disease, which is really a long-winded way of saying if you already have heart failure, we know your sleep is disturbed, but we don't know why, and now we think we know why. in mice. So that's about all from that. And I want to give a shout out to CANSI, CANSI Ontario. Thank you for inviting me. But CANSI National and CANSI Ontario, I mean, they're part of this wave of statistics and science and the outward-facing look of our department. When I started teaching, we were hoping to have 14 faculty members. We had about 10. Now we have lots and lots, but we succeeded in doing that because the whole discipline became more outward-facing and less turned in on our own theories and our own ideas, and more interested in looking outwards and collaborating and so on. And I think that's, I said I would, in my abstract, I would hazard a guess about the future, but I'm very nervous to do that. But I do feel like there's, in addition to all the strides that are being made in computational methods and artificial intelligence and machine learning, there's a huge future for statistical science, for statistical thinking, for reasoning with uncertainty, understanding that people aren't predictable. I think it can only grow from here, and I'm very excited that it's grown so much over my career, and I'll turn it over to the young people to take it forward. Thank you.
Thank you. We'll do a Q&A. Just, is there another mic? Or I just think I have this for the Zoom. I'm not phone addicted millennial. Okay. So you can use this one. Okay, thank you, Nancy. I'm feeling very mixed about my tattoo now. I was feeling good, and then, next slide, feeling very bad. Okay. So we'll do it in the room first, okay? And then I will read the Zoom questions off the chat, because I don't think you can unmute. So we'll go here first, and then pass around.
To the extent that you interact with the private sector, how has the growth of data science as a profession misused statistics?
Well, to the extent that I interact with the private sector, very little, but that's a big qualifier because I don't have so much experience outside of academia. But I do, I mean, of course, CANSI, one of its thrusts was to branch out across campuses, but also to branch out outside of campuses to industry partners and government partners. And I'm really not the right person to ask, but I would say that there's probably a gap between what managers and upper level management and so on think they need from statisticians and what statisticians can offer. At least that's what I hear. But I hear that, how should I phrase this? Students who go out to work in the private sector who are pretty creative about selling what they can do seem to succeed very, very well, because people might not know that they need statistical thinking, but they do. And when you can kind of persuade the people that you're working with that that's going to be helpful for their bottom line, then I think it's always a win. You know more about this than I do, so I'll stop there.
Thank you. I really enjoyed the lecture. If you could wave a magic wand and change one thing about the way news media communicates results, what would you change?
I guess I'd suggest that if it sounds implausible, they should have another look. There's a kind of common sense factor in all of this, and I think the need to drive clicks or to sell newspapers in the old days sometimes overrides that kind of common sense caution So maybe, yeah, if it sounds too good to be true, it probably is too good to be true. I do think that the news organizations have gotten much better over the years. Not always, but mostly. You know.
I just want to say thank you for the lecture. I really enjoyed it. We are like students at U of T studying statistics. What are some things that you think we can do to help prevent all these miscommunications in the press, in the public, or in politics?
I guess just talk to your circles, so when I was a student, well, of course it's a long time ago and maybe not relevant now, but most people were puzzled at why would you study statistics? Don't they already know everything about that? And it's isn't that just like a government job where they collect numbers? And I don't think that view is so pervasive anymore, but I think there is still some kind of uncertainty about what exactly one does. And I would say meet them at their level and talk about stories like this, like, you know, some of the medical stuff that you hear hasn't been properly tested. Some of it has. I should have had some more positive ones. I apologize, but somehow it's fun to find the ones that make mistakes. But there's some good ones as well, and so I think it's just kind of like conveying to your non-statistician friends that there's really a lot behind it that's of interest, and if it's, again, like, use your common sense. If it sounds too good to be true, it probably is. It's tricky, I agree. There's lots of these kind of miracle treatments come along, and then you have people saying, oh, have you tried this, have you tried that, I heard this works, I heard that works. And you can't always just be saying no, 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 but you can sort of say what's involved in making sure that it works, and in a kind of low-key way that's not too argumentative, I guess.
Okay, so we have 2 in Zoom, and then I think we'll end it after that. And some people are asking for the recording, so the first one is Catherine asks, where, if anywhere in particular, do you think efforts should be focused on statistical education? Is it our undergrads, or should it start earlier? Thanks for the great lecture.
Oh, it certainly could start earlier, and I guess it does in a way. There is some work in the schools and even in elementary school and in the high schools on kind of statistical thinking. I think the general consensus is that it's still not terribly well taught at that level, so there's maybe a need to get to the teachers to kind of with this type of material rather than all the rules that statisticians throw up, which tends to be how people view it initially until they think about it a little bit. So, but I think the earlier the better. And you can start with pictures, of course.
Okay, so the second one is from, I think, Reem. Thank you for this amazing talk. Can we summarize statistics about the collection of data and their analysis, or is there another way for learning, teaching, doing research in statistics besides the fact of having access to data?
Well, I've spent my whole career doing theoretical statistics, so I think you could describe statistical science in many ways, but one way would be thinking about this data and how to collect it and how to analyze it. And then another way to describe it would be to think about the ways that you choose to analyze it, how well they work. If you use them all the time, that's kind of the stepping back a little bit. It's hard to explain in a very general setting, but I think it's possible that it's a kind of study of how all these different, say, hoops that statisticians seem to make people jump through. Why are they there, and what good are they? Why do we think they're useful? So it's maybe a step back from just collecting data and analyzing data, but thinking about, are there some common threads in analyzing the data that people will use in climate science, in astronomy, in social science, psychology? Can we find some common principles and study those? That would, I guess, be my approach. These are tough questions.
Yeah, they're all tough. Yeah. Okay, so the last one, I'll read the last one from Zoom, and then I think Nancy, you'll be around for a bit after for the reception, right? Some people may ask. So, okay, the last one is, do you think causal inference as a field of study and research aims to address a lot of the problems that you mentioned during your talk?
Yes, certainly. If you want to make claims about causality, then you need to think really hard about how you could do that when you have observational data, and I think there is an appreciation for that, and causal inference is the field that's pushed that along. It's not the only field of interest to make statistics more relevant, but it's one of them for sure, yeah.
Okay, so I guess I'm closing it out, right? So thank you everyone for coming, and thank you Nancy again. So